For benchmark 2e, we want to solve this. And when we're solving an xyz equation like this, we're trying to find x, y, and z. That's what we're trying to find. In order to do that, my first step is I like to label each equation. I'm going to call this my first, my second, and my third. And once I do that, I simply want to make a fourth and fifth equation by getting rid of a variable. When I look down, I see these x's, these y's, and these z's, and I look, okay, which one would be easiest to try to cancel out with elimination? Z looks pretty preposterous because it's kind of big numbers. Y looks okay, but look at this. Aren't those pretty small values? So what I do is I'm going to take the easiest two first. I'm going to get rid of x. So if I just take the first and the second, I'm going to take the first and the second. So the first is x plus y plus 2z equals 0. And the second, first and the third, this would be negative x plus 3y minus 7z equals 6. And I'm going to solve this and make a new equation with it. What's nice is the x's drop out, leaving me 4y when I add down. This leaves me negative 5z when I add down. And this leaves me 6. And I'm going to label this my fourth equation. Okay, now I want to make a fifth equation that only has y's and z's. So I got to get rid of x again. So what I'm going to do is I can choose to get rid of two different equations again. I have to use the second equation, so I'm going to start off with the second equation, which is 2x minus 6y plus 5z. I have to use that equation, and I can use the first or the third. I'm going to use the first. And what do you need to do? I need to make that into a negative 2x, my first equation. In order for the x's to cancel, that has to become a negative 2x. So I must actually multiply the whole thing by a negative 2. So that I get a negative 2x and it cancels. So when I multiply negative 2 times x, that's what we get. Negative 2 times y is negative 2y. Negative 2 times 2z is negative 4z. And negative 2 times 0 is easy 0. And the x's disappear. The y's end up being negative 8y, and the z's end up being 1z equals 6. And I call this my fifth equation. To recap, we take two sets of equations, cancel the same variable twice, make a fourth and fifth where we can now, with this fourth and fifth equation, solve them using elimination. The key is these two new equations have to have the same variables. So let's solve the fourth and fifth. So I can either cancel out the y's or cancel out the z's. Well, I can make both of these into 8s. I can make both of these into 5s. I think it's easier to make both into 8. So I'm actually going to multiply this by 2. And when I do that, I'm going to bring this equation down here. I get 8y minus 10z equals 12. And when I solve that, when I combine and eliminate, those cancel, leaving me negative 9z equals 18. These cancel. And then if I divide by negative 9, I get z equals negative 2. That means z is negative 2. So we got one piece of our problem. How do we find x and y? Well, aren't we solving the systems right here?
Yes.
Didn't we just get z? So can't we take z and go plug it back into one of these two?
Yeah.
So I'm going to take this and just take it right up here and plug it right there. So I have 4y minus 5 times z equals 6, and z is negative 2. Let's solve it. 4y, negative times a negative is a positive. minus the 10 over. We're just solving this. And when we divide by 4, we get that y equals negative 1. Cool. So we basically made two equations. We solved the fourth and fifth, got our y and z. How do you find your x? Well, you take these two values, and can't you just plug it into one of your first three? Now, hopefully you can tell that the first equation is probably the easiest, smaller numbers. Doesn't matter which one. It's just ease. So for ease sake, I'm going to use the first equation. X plus y is negative 1 plus 2 times z. Z is negative 2. That equals 0. So I'm simply going to solve this for x now. And I have my last variable. So x minus 1 minus 4 equals 0. So x minus 5 equals 0. If we add the 5 over, x equals 5. We now have our answer. At 5, negative 1, negative 2. If you plug that into here, you'll get 0. If you plug it into this equation, you'll get 6. If you plug it into the third equation, you'll get 6. That is the solution to this system of equations. Make two new equations, solve it. Those results plug into one of the originals, and you're done.